This one is for Module 1, Lesson 4, Equivalent Ratios. In this one, we'll talk about how you can solve ratio problems by finding equivalent ratios. This is kind of a continuation of Lesson 3. We're still going to focus on how you can find the missing value and identify that missing value by finding the value using tape diagrams and using multiplication or the giant one. We're going to work on both those methods today as we get going through here on this problem. So as you get working through these, that's what we're going to be working on. So let's go ahead and start with the first problem here. So this first problem in the morning announcement said that 2 out of every 7 6th grade students in the school have an overdue library book. Jasmine said that means that 24 of us have overdue books. Grace argued, no way, that is too high. How can you determine who's right? So on this one, it kind of depends. So this is kind of an open-ended question. You just got to kind of decide what the actual possibilities could be. So if you're going to look at that, so they kind of give you a ratio here. They say 2 out of every 7. So in this case, they don't specifically give you the ratio, but that's another way to say a ratio is 2 out of every 7. So our ratio is 2 to 7, where it's 2 is, so 2 out of every 7 have overdue library books. So 2 is the overdue, and every means total 6th grade. Okay, so 2 out of every 6th graders have an overdue library book. So then Jasmine goes on to say that would mean 24. So if we do our tape diagram, if we start with 2 to 7, so these are our overdue, and these are our total students. 2, 3, 4, 5, 6, 7, 2, 3, 5, 6, whoops, one more to get my, so there is our tape diagram. Okay, so 2 out of every 7, so she says that means 24 of us would have overdue books. So she's saying that means 24 there would have overdue. So if that's the case, it's like we did yesterday, that means this 24 would be split into 2. So if we divided that by 2, we would have 12. So that's saying that each one of these boxes or bins is 12. And since these bins are all the same size in the ratio, that means each of these would be 12. So since there's 7 of these, that means to get how many total students, we would take it and it would be 12 times 7. So 12 times 7, that would be 7 times 10 is 70, and 7 times 2 is 14. So we add those together, and that would give us 84. So that would be the total students. So 84 total students. So in this case, if you're looking at our 6th grade, we have over 100 students. So that would be, in no way would it be too high. So that's what they want you to do on this one, is just kind of think through it. There is no exact answer. But in this case, it could be a reasonable ratio for our group, because 2 out of every 7 would only mean 84 students. So that's well within our amount. So if 24 students had it, you could even have a few more that would have an overdue book. So again, just thinking through it, following our tape diagram. You could do the same thing with a giant one, but I'm not going to worry about that right now. If you did that, what you would multiply by would be 12 over 12 would be your giant one. Okay, so let's go ahead and look at the next one with this one. So this one is giving you a couple of ratios. If the ratios are equivalent, fine. Okay, first of all, determine if the pair of ratios are equivalent. If they're not equivalent, they want us to come up with a ratio that is. So, and if they want us to see, now this C that they're talking about here, that is actually our giant one. So that's what they're talking about here, what you can multiply it by. This is our giant one. It's what you can multiply each of the numbers by to get the other number. So it's basically saying it's what the giant one is made out of. We're putting C over C. They're just saying, what can I multiply both these by? So if we look here at this one, you look from 6 to 42 and 11 to 88. And we're saying if we look at it this way, so let's go here, 6 over 11. What can we do to get to 42? Is that equivalent? And we say, well, I know that 6 times 7 gives me 42. So if we put that in as our giant one, then that would equal 77. So that one's not equivalent, is it? So that one's not equivalent. So one equivalent ratio would be 42 to 77. Now you could have also said, well, I know that 6 over 11, so 6 to 11. I know that I can get the 11 to 88 if I multiply by, again, I'm going to use a giant one in this case. I'm going to multiply by 8 because I know that will give me 88 on the bottom. And if we multiply 6 by 8, that would give us 48. I know 5 times 8 is 40, so 8 more would be 48. So that would be another one you could put over here. Is that? So that one is not equivalent. So no, and then we can figure it out. So our next one here, 0 to 5 and 0 to 20. So we ask ourselves, can we get here, if we put 0 to 5, is there something I can times that by to get 0 to 20? Now you have to be careful on this one, because if I said, yeah, I'd put 0 over 0, and then I would end up with 0 over 0. So you'd say, oh, it's not equivalent. So you never use 0 in a giant 1. So that's one thing you want to be careful of. You can never use 0 in a giant 1, because we don't use 0 in a giant 1 because we never have 0 in a fraction. Okay. So again, we said ratios not all ratios are fractions, so we don't use zeros in fractions, but we can use them in a ratio here. So we could put a giant 1 in here and multiply that by, what do we times 5 by to get to 20? Say, oh, I know I got to times that by 4, times it by 4. So that one is work out, and the C we use is 4. So that's what we're multiplying each of them by. So that's what it's talking about. The C, that's what we're multiplying each of them by. Multiply them each of them by 4 to get those equivalent. Okay, so that's what you do on that lesson. Now there's just one more problem we want to go over on this one, okay? So let's go ahead and look at it. And if you need to pause the video and try this problem on your own, I encourage you to do that because it's a pretty good problem. So exercise 2, in a bag there is a mixed walnuts and cashews. The ratio of the number of walnuts to the number of cashews is 5 to 6. So they give us the ratio. Determine the number of walnuts that are in the bag if there are 56 cashews. So we know that, and then they want us to use a tape diagram to support your work. Justify your answer by showing the new ratio you created. Number of walnuts, cashews is equivalent. So they want us to use a tape diagram and to justify that. So the number of walnuts to cashews. So let's go ahead. So walnuts is represented by 5 in our tape diagram. So 1, 2, 3, 4, 5. So there's our walnuts. And our cashews are 6. So 1, 2, 3, 4, 5, 6. Okay, so there is our walnuts and our cashews represented in a in a tape diagram. And we know in this case that there are 54 cashews. So that's the number of cashews down here. We know that that is a total of 54. So that tells us we're splitting the cashews up by 6. So we're splitting those cashews up by 6. So we need to ask ourselves, what is 54 divided by 6? And that is 9. So that means each one of these boxes or bins is 9. And so this one up here would equal 9 times 5. So that's how many walnuts there is. 9 times 5, so that would be 45. Now they want us to justify it by showing that justify your answer by showing that the new ratios you created, number of walnuts, cashews are equivalent. The way I would show they're equivalent is I would use a giant 1. So we have our 5 to 6, we multiply that, and our giant 1 is going to be made up, again, it's the size of what goes in our bins here. That's going to be made up of 9s. So we're going to multiply by 9 over 9, and that's going to justify those are equivalent. So we're going to end up with 45 over 54. And that is true because we're multiplying by 1, and when we multiply by 1, we don't change the value of it. So that's our justification right there. Again, you'll be able to solve these problems using either method when we get going on from here. But again, make sure you know how to use a tape diagram, and I would accept either one of these methods as a justification on the test. So make sure you can do either one of these methods. So good luck, and let me know if you have any questions. Have a good day. Bye.